Let's go. Let's see what's up. Let's see what we're doing. Hey, we got a problem. And we're going to talk about shells about the x-axis. Oh, x-axis. Going about the x-axis. Okay. Let R be the region in the first quadrant bounded by the graph of y equals the square root of x minus 2 and the line y equals 2. And we want to find the volume of the solid generated when R is revolved about the x-axis. Okay, so if we're using shells and we're going about the x-axis, what does everything need to be in terms of? Y's. The problem gave us y is equal to the square root of x minus 2. Shoot. So we might want to take this and solve for x instead, so we can get a function in terms of y. So we square both sides, and we get y squared is equal to x minus 2. And then we add it over, and we get y squared plus 2 is equal to x. Therefore, we can say that our function in terms of y is y squared plus 2. Neat. And I'm trying to stay away from doing a lot of graphing, a lot of sketching, even though you should always sketch something. Just give it a quick sketch, just so you can take a look at it. And we'll do that. We'll do a quick sketch, but I'm not going to give you all the fancy pictures. So, all right, so we have our function, and then we remember to get our volume, we had 2 pi from a to b of x times f of x dx, but this is for when we revolve about y. We're going to do this about x. So our volume is going to be 2 pi from some c to d of y times an f of y dy. That's about the x-axis. So again, shells are backwards. Go about the y-axis, need it in terms of x. Go about the x-axis, need to be in terms of y. So that is the opposite of of disks and washers. So, I mean, we're ready to go. It's 2 pi y times y squared plus 2 dy. But where I need a picture, some sort of sketch, is I don't know the bounds. I mean, I can do the lower bound. I know that this is going to be 0. I know for absolute gosh darn certainty that's going to be 0. So let's just do a quick sketch. First quadrant. So I'm going to draw this. I'm not very good with turning my head around and thinking about y squared plus 2 and graphing that. So that's from 2, and it goes something like this, and it takes off forever. And we only want to go to what values? What's the question say? We want to go to y equals 2. So up here. Okay, so there's our region. There's that region that we're going to want to take and revolve about the x-axis. Oh, there it is. I don't need to draw anything else. There's 0 up to 2. There's our bounds. It's telling us it's from 0 to 2. Done. No more need to draw anything. Because if we're going about the x-axis and everything is in terms of y, right? You got y's written there? Your bounds better be frickin' y's, not x's. Not x's. So we have our, just in the picture, I can't help myself. It doesn't go that way. See that? How we're used to, like, it goes that way? That would be in terms of x. Our heights are actually going this way, because this is not, we're not thinking about it in terms of x, we're thinking about it in terms of y. So there's our heights, our y squared plus 2. And our radius just being the y value. That's the y value, that's the radius for wherever we may be. All right, let's get it. Let's solve this very, very simple integral. Because again, it's not about the integration. It's about the setup. I know I've already said it, but expect this on an exam. You will have at least a problem where I'm just going to say, just set the bad boy up. Let's go. So there's our volume, and now let's integrate 2 pi times, what is that, y to the 4th over 4. plus, what is that, just y squared? Because we divide by 2. And then we go from 0 to 2. Let's actually solve this one. This one is reasonably mellow. So we have 2 to the 4th over 4 plus 2 squared minus absolutely nothing. Zeros are the freaking best. So we have 2 pi times, was that 16 over 4 plus 4. So the 4 plus 4 is 8. So we end up with just 16 pi. Hey, there's our answer. Not that tough of a problem to solve with the integral, but how do you set it up? Especially when this problem gave it to you and y is equal to the square root of x minus 2. Be ready to have to solve for the other variable. Know that that's a possibility as you're going through your checklist. Yeah, buddy. Yeah, buddy. Okay. We'll do another fun one. And these are going to get a little funky. Just a little funky as we move on. So we're going to do it about other lines. That's going to be a little rough. We're going to find the volume of the solid generated about another line. Not just the y-axis or the x-axis, but maybe like a number. All right.